Alrighty. My project is developing zero trust architecture in a medium to large organization. Zero trust architecture is a modern security framework that changes how networks are secured. It operates on the principle of never trust, always verify. And it treats all users and resources as potential threats until proven otherwise. It goes off of guilty until proven innocent. Uh, it eliminates trust within a network to mitigate the risk of internal and external threats to network security. The problem that my project aims to solve is the with the rise of Internet of Things devices and organizations moving to the internet, this causes the attack surface of all these organizations' networks to increase. And with the increased complexity of attacks and the increased frequency of attacks, traditional architecture like perimeter based and trust based no longer work. So, this is where zero trust architecture comes in. The different components of zero trust architecture: identity and access management. So, this plays a huge role because IAMs, they manage user identities, access permissions, and they generate activity logs. And they basically define access policies, which are used by PEPs to authenticate users. Network segmentation. This is where the network is divided into different segments to basically make attacking an organization harder. It limits lateral movement and it helps contain breaches better. Micro-segmentation takes it a step further, but instead of random segments or strategic segments, it segments each resource on the network. And PEPs will act as the gateways between these segments, enforcing access policies and facilitating network segmentation itself. Continuous authentication and authorization. This is important in ZTA. Every access request is authenticated and authorized, and even if you have already been authenticated and authorized, it will make you redo it after a certain period of time. And PEPs are what enforce these policies. PEPs, they are logical components responsible for enforcing access policies defined by IAMs. They are typically positioned at the network perimeter and within segments, and PEPs grant, monitor, and revoke resource access. They typically leverage information from IAMs, CMs, which are monitoring systems that aggregate logs and information from all other systems, and then any other network systems to make informed access decisions when authenticating and authorizing users. Encryption is important. Uh, Encryption, it safeguards sensitive data during transit, at rest, and during processing within ZTA. Advanced encryption methods such as fragmentation and homomorphic encryption, they ensure data security against attacks and breaches. Visibility and monitoring. So, monitoring systems provide comprehensive visibility across the network by tracking user activities, network traffic, and application behavior. They collect data from designated sources to detect anomalies, identify threats, and mitigate security risks proactively. Uh, Network transparency is what this is. Automation and orchestration. So, ZTA leverages automated and orchestrated security tools to enhance network security. And this is done to minimize human error, increase operational efficiency, and respond promptly to security threats. An example of this would be IAMs, PEPs, and CMs working together to achieve authentication and authorization. The results. So I, in this project, I developed a ZTA. So it was tailored for a small Linux VM server due to resource constraints, and it was based on a pure zero trust architecture approach. Cloudflare was a huge component. It was used for IAM, PEP, and data encryption during transit. Uh, Default firewall CMD tool was used for segmentation of Linux VM. Uh, all default ports were denied, and only ports that I needed for my services were allowed. Data encryption was automated during installation, and visibility and monitoring were facilitated by Prometheus and Grafana. Fail2ban and mod security, those are the IPSs. They were installed on the web server to complement each other for defense in-depth strategy, focusing on preventing brute force attacks, which is Fail2ban, and then addressing general threats as a WAF, which is mod security. Implementation of the ZTA. So the first step was a minimal CentOS installation in a Linux VM. I use that due to my I have experience using it in previous classes. I configured the network to use NAT networking and port forwarded rules for all the services I would need. Disks were automatically partitioned and encrypted using the loops format during the installation. User accounts, root, and gleonard were created with passwords that are complex. The server package Apache was installed with HTTP and HTTPS traffic enabled through the firewall. Domain registration with Cloudflare, that is the domain name, and nrock is a reverse proxy. And what it does is it connects my VM to the internet, and then Cloudflare is connected to that tunnel to allow for network access from any device. Like you could try to connect to my website right now and try to log in. Uh, Cloudflare is the proxy. It provides IAM, PEP, and monitoring functionality. Authentication controls are integrated using Google Login via Google APIs. It's integrated into Cloudflare. Prometheus and Grafana were installed for network monitoring. Grafana visualizations were configured using Prometheus's data. Fail2ban, mod security are installed for defense in-depth strategy. They provide brute force protection and WAF capabilities, respectively. In my testing and findings, I used Skipfish on a Kali Linux VM to scan for any vulnerabilities in my web server. Initially, there was 18 medium threats. Got those down to just 4 notes and 1 connection warning. I had to do some research, but I got rid of them. Access controls were thoroughly tested, so I used different devices, different accounts to try to log in. Only the ones that I authorized were allowed to log in. And what I found is, with the flexibility of all these tools, ZTA is perfect for medium to large organizations. The conclusion is what I was saying. ZTA is perfect, flexible. It's good. Now, this is the fun part where I show you all this different stuff I used while I still have time. This is the encrypted file, so I'm just use the password for that to get into the VM itself. You have to wait for it to load. It'll take like 20 seconds. And then log in as root. There we go. Now we will activate the web server using nrock. We will close out of that. Now here is Grafana. So these are all the services: Prometheus, Apache, Grafana itself. This is all the data visualization. You can do a whole bunch more. I just did the basics to show you. Here's Prometheus. This is nrock itself. This is showing you all the connections and everything. The tunnels and stuff. My domains. I think this is a traffic inspector. Yeah, this is it. This is the Zero Trust Cloudflare. So this is where my access point is created, my gateway. I have all my tools here. Authentication, Google, I have all my policies. The policy itself only accounts with these emails are allowed, which is how I did the filtering. Here is the main dashboard. So my DNS, the CNAME. This CNAME is from nrock, which allows me to connect and do the whole gateway system. This is like my security for certificates, my other security settings right here. Hi, blah, 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 blah. Now for the fun part. So I'll log into my domain. It sends me to Cloudflare Access. You have to hit Google, and it signs me in because of the cookies already saves my login. But this is my website. So that is my presentation on Zero Trust Architecture, which is the future of security frameworks. Thank you.